In order to answer this question, our first step is going to be to write down a precipitation reaction between potassium chloride and silver nitrate. So let's go ahead and begin to set that up. In a precipitation reaction, the positive cation in the first substance is going to partner with the negative anion in the second substance. So in this example, we would have the potassium ion, which has a charge of +1, partner up with the nitrate ion, which has a charge of -1. Notice that because those charges are equal in magnitude but opposite in sign, they would essentially cancel out, and you are left with the formula KNO3. And we know from our solubility guidelines that any ionic compound that contains the nitrate ion is going to be aqueous in solution. So that would be the correct product for potassium nitrate, and now we have to take the positive cation of the second compound and partner that with the negative anion of the first compound. And silver has a charge of +1, chloride has a charge of -1, and once again, equal magnitude charges, opposite sign, they're going to cancel. Now, again, hopefully we know from our solubility guidelines that silver chloride would form the precipitate. So this would be the solid substance in the product. Now, this reaction is balanced. You might want to pause the video and just ensure for yourself that it is indeed balanced. After writing down the reaction, the next thing we want to do is start out with our volume of the silver nitrate solution. Now, that volume is in milliliters, and what we're going to need to do is convert that into liters. So this is 15 milliliters of the silver nitrate solution, and we know hopefully that when we have 1 liter of silver nitrate, that would be equal to 1,000 milliliters of silver nitrate. Now, you might want to ask yourself, why did we set up the conversion in this manner? And the reason is that the milliliters are going to cancel out, and this leaves us with just liters of the silver nitrate solution. And that's actually useful, because once you have liters of silver nitrate, you can now turn over to the molarity of the silver nitrate. Now, recall that molarity, although it's often symbolized with a capital M, is equivalent to moles per liter. So when we say 0.2 molar, what we really mean is that we have 0.2 moles of silver nitrate for every 1 liter of silver nitrate. So basically what you're doing there is you're changing the capital M into a mole per liter unit. And setting it up in this manner allows us to cancel out the liters of silver nitrate. Presently, we have our unit as moles of silver nitrate. We're getting there, but we're trying to figure out ultimately the mass of KCl. And so we don't want moles of silver nitrate. We have to go a little bit further, and this is where the reaction comes in. If you look at the balanced reaction, we can see that 1 mole of silver nitrate reacts with 1 mole of potassium chloride. So that would be our next conversion. We would say on the bottom 1 mole of silver nitrate reacts with 1 mole of potassium chloride. Now, again, arranging the configuration in this manner allows us to cancel out the moles of silver nitrate. And now we're left with moles of KCl. One more step, right? Because we have to get the mass of KCl. And to do that, we're going to have to take a look at the molar mass of KCl. To get the molar mass of KCl, you simply look up the mass of potassium and the mass of chloride, and then you add them together. And when you do that, you're going to get a molar mass of 74.5513 grams per 1 mole. So the way that you would set that up in your final conversion here would be to say that 1 mole of KCl has a mass of 74.5513 grams of KCl. So there's our final conversion. If you study that carefully, you will see the moles of KCl will cancel. We are left with our final unit of grams of KCl. That would be the mass that we were looking for. And then when you simply punch this all into your calculator, you will get a mass of approximately 0.224, and then this would be grams of KCl. And so this would be the correct answer to the question.